Welcome to the next module in the elicitation and analysis domain. In this video, we focus on a key activity that supports clarity and shared understanding, using modeling techniques in business analysis. This module forms part of Module 5, the elicitation and analysis domain, and it builds directly on the confirmation activities introduced in Module 5.5. If you haven't watched the previous module yet, I encourage you to do so to understand how validated information forms the basis for effective modeling within the broader PMI-PBA journey. In this module, we'll explore commonly used modeling techniques, when and why they are applied, and how visual representations can simplify complex information. These models help clarify requirements, reduce ambiguity, and support collaborative analysis across stakeholders and delivery teams.
Once requirements have been elicited and confirmed, the next challenge is making sense of them. Raw requirements, even when well written, can be overwhelming. This is where modeling comes in. Models allow us to translate requirements into visual, structured, and testable forms. They provide a common language that stakeholders, business analysts, and technical teams can all understand. Instead of wading through dozens of pages of text, a well-designed process flow or use case diagram can instantly clarify what's being asked for and how it fits together. Different models suit different needs. For example, process models are excellent for clarifying workflows, data models highlight information flows and structures, and user interface wireframes bring a solution to life visually. The choice of models should always be guided by the audience and the context. In practice, modeling is not about producing perfect diagrams for the sake of documentation. It's about creating just enough structure to bring clarity and alignment while keeping the focus on business value. Next, we'll look at some of the most common modeling techniques you'll encounter in business analysis and see how each can be applied in practice.
There are many different modeling techniques available to business analysts, and each serves a different purpose. Let's explore a few of the most common ones. Use cases are a staple technique. They describe the interactions between a user and a system, outlining the steps needed to achieve a specific goal. For example, a use case might capture how a customer places an online order, from logging in to selecting items to confirming payment. This gives both business and technical teams a clear view of the end-to-end interaction. Story mapping is especially valuable in adaptive environments. It allows us to break down large initiatives, often called epics, into smaller, manageable pieces like features and user stories. Think of it as laying requirements out along a timeline of the user journey. This helps teams prioritize what to build first and ensures early releases still deliver meaningful value. Data flow diagrams focus on the movement of information. They illustrate how data enters a system, how it's processed, and where it flows next. For example, in a payroll system, a data flow diagram might show how employee timesheet data moves through validation, calculation, approval, and finally payment. Wireframes and prototypes bring design and functionality to life. They allow stakeholders to visualize what a screen, report, or product might look like before it's built. Even a simple sketch on paper can spark valuable feedback that words alone can't achieve. And finally, decision tables or state diagrams are useful for capturing rules and behaviors. For instance, a decision table might clarify the rules for granting a bank loan, showing how different combinations of income, credit history, and collateral result in different outcomes. Each of these techniques gives stakeholders a different lens through which to understand requirements. The key is choosing the right model for the right context, keeping it simple enough to be useful, but structured enough to remove ambiguity. With these modeling tools in hand, the next step is defining and elaborating requirements so that they move from high-level ideas into detailed, testable statements.